Okay, so chain rule for math, there's two parts. There's an outside and there's an inside to an equation. The way you want to go about it is you want to multiply the exponent with the outside. So for example, for this equation right here, the -7 at the beginning is multiplied by the 5 exponent. So you end up with -35 parenthesis x squared plus 8 to the power of 4. And then you multiply that by the derivative of the inside right here, which is x squared plus 8. The derivative of that is 2x. And that would be the chain rule in action. That's just like the very basic of it. If you want to get more complex, chain rule level 4, you have a most inside, a second most inside or outside, and then just a regular inside. So first, you start with moving this 3 from the outside. With this -3 over here, you get negative sine squared, parentheses 2x squared plus 3, right? That's all the inside. The inside part stays the same. Then the second most inside changes, that being the sine. That just becomes cosine, parentheses 2x squared plus 3. Notice how I no longer have the -3 is gone, the -9 is gone, and the exponent right here is gone. So the only thing that really changed here was the sine becoming a cosine. And then the last one is the most inside, which is just 2x squared plus 3. The derivative of that is 4x. Then, you'd plug that in and you'd get the answer. There's a small thing that we had to memorize for the notability. The derivative of a to the power of x is equal to a to the power of x times ln of a. And then log a of x is equal to 1 over x times ln of a. Pretty simple. I think you guys can remember that in time. Next is the implicit differentiation, which is a little bit harder. It's basically the same thing as finding a derivative, except there's just one small itty-bitty change. So let's look closely over here. So when you're trying to find the derivative of x on its own, you just move it over and it becomes 1. And if you're trying to find the derivative of x squared, you move over, you get rid of the one exponent from here and move this exponent back, right? Simple as. However, with this one, you're just multiplying it by whatever number you get for that. It's the same thing, except you multiply it by y prime. So instead of x becoming 1, it's y becomes 1 times y prime, or just y prime. A simpler one to look at would be y squared right over here. It becomes 2y times y prime. Same thing. See these two things right here? One and the same, except one of them has y prime here instead. You always want to add a y prime to the end of these when you're finding the derivative of y specifically. Couldn't tell you why, but you need to know that for the quiz. Now let's take a look at implicit differentiation 1. This is the easiest one, but don't get confused, this is still hard. First, we have this equation right here. -4y minus 5x squared is equal to -x minus 2x to the power of 3 plus 5y squared. You find the derivative of this, which is -4y prime, right? If you remember this thing right over here. Then simple for this one, -10x, -1, -6x squared. And then for this one, same thing as this one over here, you get plus 10y times y prime. Then you want to move all the y primes to one side. You can see I've done that right here. You want to factor all these y primes like I've done right here. And then you want to divide this number by this number right here. And you should get something like this. Now, on the delta math for this assignment, it has it as dy over d of x, and that's the same thing that we had on the notability. He's been pretty stingy on, or pretty strict on notation recently, so you might want to write at the end dy over dx just to, make him happy. but you might also be fine if you just leave it as y prime. Implicit differentiation, you have negative 3 is equal to negative x times y plus 4y. You want to use the product rule for this part right over here. So first, negative 3 is 0, but if you remember the f of x prime times g of x plus g of x prime times f of x, that's basically what this is right here. I'm just gonna, this is the product rule in action. Right, so you find the derivative of x, and then you leave y as is, and then you find the derivative of y and leave x as is. And then from there, you can just go around moving things around. You get y is equal to y prime, parentheses 4 minus x, then move it to, just, divide it, and you'll end up with y over 4 minus x. This part is probably the easiest part. The most important thing that you have to remember is the product rule. This one right here, wrote it down just now. Okay, so this one is same thing as all the other implicit differentiation ones, except there's this little exponent right here. Because of this little exponent right here, that means that there is now officially an outside and an inside, which means we're going to have to apply the chain rule. So, you move the outside right over here, 5, 4, and then you do the derivative of the inside right over here. And then you also have to do this part right over here, which gets you 3x squared. You move around the things just to get y prime on its own, and eventually you should end up with this answer. Be very careful to not screw up a little bit, because I was looking at it and I almost screwed up. It's 1 plus 3y squared, not 1 times 3y squared. That's why this is right over here at the end, and its own little area. So this one is, you have to pay a little bit more attention, but you should be fine, and you should be able to do the delta math with just this.